Okay, now that Landsat is downloaded and added to your map, we want to learn how to use it. As I explained, you can add every band separately. Like here I have band 10, which is the surface temperature, but I can, for example, bring band 2, I can bring band 3, 4, and 5. Um, and as you can see, they detect different things depending on the wavelengths that they are picking up. You should imagine that there are multiple cameras and sensors on the satellite that is picking the wavelength in different spectrums. That's why each of these layers show different basically features of the land cover properties. Okay, now that you have that, let's go back to the handbook here, and I want to show you where you can um, get the properties. Actually, it was here, um, this one, this page, which is Landsat Collection to Level 2, and we want to basically use these multipliers. So we want to first multiply the value of um, layer um, by this number and then add -2. I'm copying that. As you can remember from last semester um, or previous year, we need to work with the special analysis toolboxes for doing raster calculations. Where is the special analyst? Here it is um, in tools, and map algebra is the tool that does the calculation for rasters. So I'm going to open map algebra, and if I want to, for example, work with band 2, let me find band 4. This is band 2, the reflectance of band 2. Then we said, let me multiply this. We said we are going to multiply the number, uh, this number, and then after that, we are going at -2, which is basically subtracting 0.2 from this value, and that will be basically band number 2. And I can save that here as, for example, scaled um, value of band 2. Let me do it. I'm going to change ArcGIS, and I'm going to put that data Landsat. Here's it, Landsat, and this is band 2. Let me find band 2. Everything is so, these names are so long. Okay, this one. So I can add scaled to this, meaning that this value is scaled, and when we save, when we run, the new layer will be scaled. If I need to do some equation, here it is, and as you can see that this is a value of, between minus -0.1 and 1.2. Often, let me go to the histogram of this layer, classification, classify histograms here. You can see where those values are distributed. Um, okay, so that's how you can use this raster. Also, you can, of course, change the color ramp and everything in symbology. That was not what I wanted to do. Just wanted to see, sorry, just wanted to see the histogram of the distribution of the values. As you can see, our values mostly are around, larger than 0 and less than zero point 0.3. Okay, so let's go back to our calculations. In the calculations, where were we in geospatial here? If I wanted to, for example, um, use this band in a calculation with other bands, I could just say, okay, this is my band number 2, and then, for example, divide this with band number 3. And I could bring band number 3 here, which is here. And again, you can do that calculation here with this band and make sure that the value is scaled. So that's how we can convert these values. Let's go back to surface temperature uh, multiplier here. We want to use again these values for scaling or surface temperature. Um, I'm going to find the surface temperature band. This is the surface temperature band. Um, yep, that's the surface temperature. And I'm going to say open parentheses, multiply the band value with this number, and then add 149. If these very long names difficult to work with, which I think it is, there's a solution for that, and I'm going to show how you can do that. You can simply change the names here. B2, rename those names here. This is B5. Um, this is B4. Okay, that is, and B10 here. I'm going to change these names, and then I'm going to raster calculator. And as you can see here, now I'm dealing with these small um, titles. That's much easier to work with. And I'm going to say multiply this value by this number and add that value. This is going to be surface temperature. That renaming just rename the layer name in the project, doesn't rename the layer on your hard disk. So be careful about that difference over there. B10 surface temperature, and I'm going to say this is scaled. Okay, now we expect to see the values that make sense for surface temperature in Celsius degrees. Okay, and I'm going to turn this off, and it doesn't, I think. Yeah, so the unit is actually Kelvin. That's why those numbers are slightly different, and let me show you what Kelvin is. K to C, 273. So eventually, if I wanted to do the right thing, let me actually do it because that's not correct. And that's just could be confusing to work with. I'm going to find our Landsat and I'm going to find scale surface temperature, deleting that because that what I created is in Kelvin. So I'm going to my analysis geoprocessing and parentheses the whole thing, put the whole thing in parentheses, a minus um, 273 point, what was it, 15. Okay, so this is, sorry, this is going to be Celsius degrees now because um, based on this handbook, we know that the temperature comes in Kelvin. Um, that's why we want to add this part to this calculation. The name is still there. I deleted that, so when I generate this, that's still going to be fine. If this layer exists, the tool I think cannot replace and override, if I'm not wrong. So that number that you see here is Celsius degrees now. Now I'm going to do symbology here, and that's um, this is stretch. Stretch is just basically you don't see classes, you see just range. I'm going to use classify. Here I can see the classes. These are different methods of classification. Quantile is a good one. 10 different classes, as you can see. So we have different classes, but mostly what we see is the temperature of water is so much lower than the temperature of land that the land is basically is classified in the higher ranges. So what can we do here? One way of managing it is um, basically you know, representing anything larger than some number, for example, 20 degrees Celsius, because water is cool, but not everything else. For that, I can go to this advanced symbology option and say data exclusion, and here say um, exclude everything between 0 and I said 20. Um, so that will be excluded, as you can see, because these are on. So you can see that it is that those parts are now gone, and again my quantile is um, mostly these areas. The other method for this would be changing the classification as a manual interval. So it means I can just change these ranges here. For example, I can say 50, it just is at the top range, and I'm going also to change the color amp because a wider color range would help to have a better representation. And for temperature, this is actually a good one because it's from colder temperature, from colder color to warmer color, so that's actually nice. And then I can have a little bit more details on the, even maybe more, on the top range, and saying that, as you can see, there are so many little, the cells that have that high temperature are actually not many. Um, so maybe just let's change that. What happened? Something happened. Okay, quantile again. Oh, that's much better now. Um, so I can say even now, so that's 57, which is the max. We don't want to change the max. I'm going to say, okay, 50, and then here I'm going to say 40, maybe 45 degrees Celsius. Um, and and then we can say 40 here, and we can say, for example, 35 here. So do you see that we see more details about as we change that? We see maybe 32 here, giving a little bit more details. So now we can see the warmer parts of the city. So even if you don't exclude those lower temperature, might not be a bad idea actually just remove this exclusion and just put them in one class here and saying anything less than, let's do it. So I'm going to actually do that. These are okay. Now everything less than 20. One could be in that um, pile. This actually might be, I might be able to delete that 50 here, remove that brick. So then, what happened? Where does that go? Hmm. Instagram statistics. Oh, my colors are gone. Um, what can we do? Closing this, maybe opening again. Symbology. Yeah, here you go. So we wanted to, yeah, remove this one. So I'm going to just say 45, this one, and that could be, yeah, that's a bug. That's a bug. Anyway, so you get the idea. You can play with the very annoying classification here, and that will give you a little bit um, more detail in terms of which parts are the warmer parts of the city, and removing that, for example, maybe giving a little bit more detail um, here. Okay. Okay, now you get the idea. So the warmer parts here in New Jersey actually they popped up. So now you can see the difference of surface temperature in different areas. The airport here is pretty high temperature. Let's just go back and add different base map here, and you are ready to visualize this in a if you clean up the classes and the labels here, make them round numbers and maybe fewer decimal points. If you play with those, and then you can put it in a uh, nice layout, and that's ready to go. Let me just give more transparency here. Okay, here you go. So you can see the airport now shows up, and water is cool. Um, if we had clipped the city's boundary here and keep only cells in the boundary using raster clip tool, we would see more uh, classes or differences in the city itself. Now we don't see them, see those differences because it is really stretched between all these areas, very cold water and some warmer areas here. So, but that's okay. You can play with classification to bring those differences here in your map. Already, you can pick some areas and see which parts are um, cooler. So that's surface temperature. You need to calculate NDVI. For calculating NDVI, you need some of these bands. Read those papers, and the calculation can happen here in um, raster calculator. My advice is rename these here in your project. That becomes much easier to handle. Once you did your calculation and you got your layers, You can really delete the Landsat layers because we have so many layers here that we don't really need. Um, and you can free up the space of your computer. For example, some of these are the quality of the data. Some of this is, for example, emissivity value. Some of this one I think is uncertainty, or basically the accuracy of the surface temperature. So you can really, if you don't need them, you can get rid of them after you create it and you produce your data to free up the space. Um, and yeah, that's how you can work with Landsat data. There are some other important layers and indexes that you can calculate using Landsat bands, because we have a wide range of wavelengths here. Um, those are really good in identifying different land cover properties.